Let's start off first. So we're starting off with earthquake. What are the causes of earthquake? The causes of earthquake, we can safely divide it into two. For that matter, any disaster, you can safely divide anthropogenic causes and the natural causes. Anthropogenic causes like the construction, nuclear testing, we have the mining, we have the rock blasting, etc. And we've also seen the case study of Mount Mantap of North Korea. The natural reasons, majorly it is the internal dynamism and the plate tectonics. The earthquakes are generally seen along the interaction between the plates, the CC, the OC, and the OO place interaction, along with the divergent boundaries and the mid-oceanic ridges and the hotspot. Otherwise, you can also relate some of the surface disturbances, the avalanches and the landslides, but they are not as important causes for the earthquake as compared to the internal dynamism and the plate tectonic. Moving on. We've seen one of the major human factor that has caused earthquake, that is your reservoir-induced seismicity. And for that, we had seen the Koyna Dam. The Koyna Dam, the Koyna earthquake of December 11, 1967, which killed about 200 people, injured about few thousands of them. And the epicenter was along your Koyna Dam. This is a Koyna Dam in your Maharashtra. Okay, so this was basically your reservoir-induced seismicity. Moving on, the nuclear testing, which is one of the causes for the earthquake. That was, we've given the case study also in 2017. There was this nuclear testing by North Korea along this Mount Mantap, which actually led earthquake. There were seismic waves recorded all across, and this is the subsequent. They were recorded toward the northwest of the site, and they were picked by the seismometers all across the world. Yes. Then. What are the mechanism of the your earthquake? So first theory was given by A.G. Wegner, who said that Sial moving over Sima, as Sial moves over Sima, the Sial scrapes the Sima and then there are earthquake caused. The second was given by Harry Finding Reid. That was, he was there in San Francisco studying about along the Andreas Fault, the earthquake. And then he gave the elastic rebound theory. He says that there are faults. Along the faults, there are stresses that are witnessed by the along the rocks. Up to a certain point, the rocks are stable and they can witness, they can bear with the stresses, but beyond a point, the rocks will break. As the rock breaks, there will be a seismicity, there will be earthquake waves that will be recorded. Another dimension that you can see about your H.F. Reid theory is these are plates. The plates are moving constantly and slowly. One plate is moving like this, the other plate is moving like this. So it's basically a transform boundary. And these are the rocks. The rocks can undergo deformation, and as they have elastic type of behavior, like an elastic, the rock can stretch and they can undergo deformation. But beyond a point, the rocks will break. As the rock break, the seismic waves are recorded. And that's what he said. However, the most plausible, the most logical explanation has been given by plate tectonics, which says that the earthquakes are because of the plate interaction. The interaction can be in the form of a divergent plate, in the form of convergent plate, or in the form of the transform plate interactions. So divergent, we know that it's the mid-oceanic ridge that leads to your breaking of the rock, and along with that there is volcanism also. Along with volcanism there is earthquake waves also seen. The convergence that we have between the ocean continent, you have one, the Beni of Wadati zone along your ocean continent collision, which records all the type of earthquake: the narrow, the shallow, the deep, and the intermediate type of earthquake. The crux of all the plate interaction, whether divergent, whether convergent, or whether your mid-oceanic ridges or your continent collisions, the crux is that the interaction between the plates is because of what? The interaction between the plate is because of the internal dynamism, the mantle and the crust dynamism. So one basic reason is all the earthquakes are because of the mantle and the crust dynamism. These are the interactions. You have your convergent boundaries. The convergent boundaries, there is OO collision, OC collision, and a CC collision. There is a divergent boundary wherein the plates, they are moving apart from each other. We have seen there is mid-oceanic ridge. There are rift valleys that are created. And one of the reasons we also studied was your reactivation of an ancient fault. Any fault that has not witnessed earthquake for a longer time again gets reactivated and leads to your earthquake. One of your earthquake in India, that is a Bhuj earthquake that took place along in 26 January 2001, was because of the reactivation and of an old fault. And what is the fault called as? The fault is called as the Allahabad fault. There was reactivation of your Allahabad fault. Probably you've not written this name. You can note this name, that there was a reactivation of Allahabad fault leading to your Bhuj earthquake. Then the third type of interaction is between your transform boundary. One of the fault that we studied was your San Andreas fault along your San Francisco. That leads to this earthquake, and your San Francisco becomes your earthquake prone area. Then we have the hotspot region. There is volcanism and the resultant earthquake. The example can be Hawaiian or your French Rouen hotspot. Then this is what is your distribution of the earthquake. The distribution of the earthquake, majorly the earthquakes, they are located along your Pacific Ocean. So this is the Pacific Ocean here. This is the Pacific Ocean. And again, this is the Pacific Ocean. So along the Pacific Ocean, you will see that a majorly earthquake belt is concentrated. Here you have what type of collision? Here you have OC collision, and here you have your OO collision. So one ocean plate interacting and getting subducted. Here also the ocean continent plate interacting and the ocean plate is subducting. As the ocean plate subducts, there is volcanism as well as your earthquake. And this is what we called as the Pacific Ring of Fire. Along the Pacific, and why do we call it as the Ring of Fire? Because along with earthquake, you also have this zone as the major zone of volcanism. Therefore, it is called as Pacific Ring of Fire. The second major place where you have your earthquake is this one, your Alpine Himalayan belt. The Alpine Himalayan belt. There is interaction between the African plate and the Eurasian plate, and between the Indian plate and the Eurasian plate. Here, the boundary between Eurasian plate and African plate is not clear, and therefore there are many small islands here, small micro plates here. These micro plates subduct, leading to your volcanism and your earthquake. So your Stromboli and the other one. This is the Alpine Himalayan belt. And the third major belt is about your mid-oceanic ridge. That is your mid-Atlantic ridge. The mid-oceanic ridge and the mid-Atlantic ridge. So majorly three major belts. One is the Pacific Ring of Fire. The second is the Alpine Himalayan belt. And the third is your mid-oceanic ridge or the mid-Atlantic ridge. We have this, the earthquake location. We understood about that you can classify the earthquake on the basis of shallow, intermediate or deep, on the basis of where is the focus. Is the focus within the 70 kilometers, or is the focus between 70 kilometers to 300 kilometers, or the focus is as deep as 300 to 700 kilometers. Yes, so this is the classification of the earthquake on the basis of the focus: deep focus, shallow focus, and the intermediate focus. Then this is your seismic zonation of India. The seismic zonation of India, we have zone 2, 3, 4, and 5. Zone 1 is not there. And then you have zone 2. Zone 2 is this one. Zone 2, 3, 4, 5. This one, the north complex, the northern mountain complex, is the most seismic prone zone, and that is called your zone 5 and zone 4. So zone 5 is majorly your northeastern states and your Andaman Nicobar. Rest of the Himalayan and the northern mountain complex, which goes as far as some portions of UP and Bihar also, they are zone 4. But there are certain regions which have a zone 5 within the zone 4. That is your Jammu and Kashmir, Himachal Pradesh, and Uttarakhand. Delhi also comes under your zone 4. Then we've seen, yes, Himachal Pradesh also. There has been subduction also, down warping of a plate also. The reason your Bangladesh is formed, the reason you have a plateau of Meghalaya is because there has been, in the past also, you have seen the tectonic activities there, right? And every time understand, when a plate is interacting, सबसे ज़्यादा impact nearby areas पे हो. तो West Bengal seismic zone 5 के पास है, तो सबसे ज़्यादा impact भी उधर पड़ेगा. Then if you look at zone 2, the light one, the light color is your zone 2, and near to zone 3 is near to zone 2 is your zone 3. So this is what you can draw as in your map. Why is zone 5 the most active? It's because of the plate interaction. They are tectonically active. The mountains are still riding. It is a zone of elevation, and as the other zone are in the proximity of your active plate boundary, they become prone to the other seismic activities like this belt and the other nearby areas. Yes, Lakshadweep is given as zone 2 in majorly many of the maps. So write Lakshadweep as zone 2. We've seen the measurement. How is your earthquake recorded? There are certain seismometers that record your earthquake. So you can look at the diagram here. This is the constant, that is the constant waves that have been recorded. And as you experience, this is your horizontal seismograph, that is the vertical seismograph. Here there is continuously waves that are being recorded, and one earthquake comes and strikes here. Your P and the S wave gets recording. First is P, then is the S wave. So here, based on the anomaly, you can recognize कि कितने magnitude का earthquake है. Similarly, here also, if you look at, this is your vertical seismograph. Comes and earthquake strikes. Here it records the P wave. Again, the S wave gets recorded. So this anomaly, these recordings are used for calculating the magnitude of the earthquake by the Richter scale. Then what are the measurements for the earthquake? We have a magnitude and the intensity. What is magnitude? How much of the energy is being released? So what energy is being released, that is called as magnitude. There are two scales. One is the Richter scale. The other is the moment magnitude scale. Richter scale records 0 to 9, but they cannot record earthquake beyond a certain energy. And therefore, for that, we have your moment magnitude scale. They record the larger magnitude earthquake. And for intensity means the damage of the degree of the damage that has been done. And here it is measured by your modified Mercalli scale or the Mercalli scale.